Okay, folks, so we need to talk about more acid and bases. That's right. And we've got plenty of lecture videos to go, so we're just now along for the acid and base ride. I know it seems like a lot of information already, but guys, I hate to break it to you. There is so much more in the world of acid and bases than what your general chemistry course provided you. All right, so up to this point, we have now talked about the definition of a base and the definition of an acid as far as how it relates to organic chemistry. A base is going to be looked at as a hydrogen acceptor, and a acid is going to be regarded as a hydrogen donor. And we went through and we were able to look at some equations, and we were able to determine how something was labeled as an acid and a base and how that related to a conjugate. So in the previous video, we went through a couple of equations. We labeled it as acid, we labeled it as base, we labeled it as conjugate acid, and we labeled it as a conjugate base. And that is one type of equation that you are going to see, or question that you're going to see. So let's talk about some of these other examples that might come along with this same topic. So that way, if we do see these types of questions, it's not going to throw us for a loop. We'll know how to answer them. And I will say, I think these are a little bit easier sometimes as long as you keep the definition straight. And I'll show you what I do that helps me so that way I do not get a wrong answer when I begin to answer these questions. So here's a question that you might see in a text, or that you might see on an online assignment or on a test that's given in the class throughout the semester. Hint, hint, hint. And it says, which compound is the conjugate base of CH3OH? So they give me a couple of choices here. This really should be like an A and a B and a C and a D and an E. That's what this is after. So which compound is the conjugate base of CH3OH? Okay, so conjugate acids, conjugate bases, acids, bases. What does it all mean, right? That's the thing that people are confused with. So this is what I would suggest that you do. Over here to the side, you write down you are after the conjugate base. And we know that conjugate bases are related to acids. But based in our last video, we said that was the combo unit that came to us. When we identify the acid, the matching counterpart is going to be called the conjugate base. So what they are asking for here, which compound is the conjugate base of CH3OH? They are saying CH3OH will act as an acid, and it will form a compound. That compound is the conjugate base that they are after. So what happens to this molecule if it acts as an acid? Well, it loses a proton, right, folks? It loses a proton. That's the definition. So what we have left over is a CH3O with a minus charge, and that is the conjugate base of that acid. And that's why we set the problem up the way that we do. I think that it helps me every single time that this process goes on. So out of our choices, which compound is the conjugate base? Well, we're going to be looking at answer B, CH3O. And that is how we answer that particular type of problem. Okay? If this question said, which compound is the conjugate acid of CH3OH? So if it wanted the conjugate acid, that meant that this has to come from a base. So they are asking, what if this molecule acted as a base? What would it do? Well, a base definition means it accepts a proton. And what we would have is a CH3OH2, because it gained a proton, and because of that it was neutral, but now it's a positive charge because it has an extra proton or an extra hydrogen, so it throws it off balance. So this is the conjugate acid, if that is the question and that's what it wanted, of CH3OH. but I always write down the relationship off to the side. And the reason that I do that is because it keeps me straight. It keeps me kind of reminded of how these two terms are related to each other, and it helps me answer these problems a little bit better, because if you don't do that, sometimes this material can get quite confusing. Here's another different type of question that you might see, very similar, but this is not a multiple choice question. So up at the top it says, what is the conjugate acid of each of the following? All right, so again, I'm going to follow my own rule. Conjugate acid is what they are after, which means that it has to come from a base. So I need to look at these molecules and say, all right, if I have NH3, and that acts as a base, I get a conjugate acid. So what does a base do? It accepts a proton. That is what it does every single time. So NH3 will accept a proton. That means that this is NH4, and now there's a positive charge that's assigned to it. It was neutral. It added another positive, so it becomes positive 1. The Cl-, the same reason. If it acts as a base, it accepts a proton. So this would be HCl. This one, and it's negative, gaining a positive makes it neutral. This OH, if it acts as a base, it gains a proton. So this is H2O. And it was negative, but now it's neutral. And then finally, H2O at the bottom. If it acted as a base, it would gain a proton. There we go. It was neutral. It has an extra proton, so therefore it carries a positive charge. Those are the conjugate acids of each of the following. Also keep in mind, conjugate acid means at any point in time, these molecules could give off that proton once more. So this NH4 plus could spit off a proton. That's the definition of an acid. HCl, spit that proton off. H2O, split a proton off. H3O plus, spit a proton off. That stays true to the definition. So that's the type of question that you'll see. Hopefully, you might see that you might feel uncomfortable with these, but they're not too bad as long as you make the proper notes on the paper. Next one, what's the conjugate base of each of the following? I do this the same way. They want conjugate bases. So therefore, these molecules are going to be acting as acid. What they are asking is, if this molecule acted as an acid, what would happen? And they start us off with NH3. Well, the definition of an acid means it spits a proton off. So if we remove a proton here, I'm left with NH2. If we remove a proton, it's neutral. We remove a positive charge, this thing will now go negative. HBr, it removes a proton. So we have Br, and it's lost a proton. It was neutral. It lost a positive charge. So therefore, this also becomes negative. HNO3, it loses a proton. That's the definition of the acid, to give me that conjugate base. Well, that leaves us with NO3. If we remove the hydrogen, we remove a positive charge. It was neutral, and now it goes negative. And then H2O finally at the very bottom. Sorry, that's not a subscript, but that should be. That is acting as an acid. Acid means it spits a proton off. What we have left over is an OH. Because remember, H2O can be written as HOH. We remove that hydrogen away. We remove that proton away. We remove that positive charge away. And that makes that neutral charge become negative. So those are the conjugate bases of each of the following. And remember, conjugate bases mean the molecules are acting as acids. Conjugate acids mean the molecules are acting as base. That way, when they form the conjugates, they can actually go back and revert on themselves and go back and forth this way over and over and over. So I think that really wraps up the information that's included in the first section of this chapter in your text. And that's this whole general introduction of acid-base conjugate acid, conjugate base theory, and being able to label them and identify them in a chemical reaction. So in the next video, we will go on to the next topic of acid-base theory, and that's a revisit of pKa and pH. Again, I'm saying a revisit because pKa's are typically described in general chemistry. And depending on your experience in general chemistry, you maybe have never heard of pKa. And once more, if not, I am very, very sorry. But we're going to talk about it now. So in the next video, that's where we'll pick up.